All right, this is Student Affairs. This is our live session. So we're having a live classroom. We're also going to having a conversation with our students, our followers, and our viewers. Okay, we'll be looking at balancing a chemical equation. If you are just joining us, this is a live stream. This is a live stream. So in this live stream, we would like to take your contributions on the comment section. So in this live stream, we'll be looking at balancing chemical equation. This is actually the part 2. If you are just joining us, this is our live section, Student Affairs. So let's look at the first. We'll be dealing with two chemical equations here. You know, balancing a chemical equation, the purpose is to make sure that the number of atoms of elements on the reactant side is the same as the number of atoms of elements on the product side, because the law of conservation of mass states that matter can neither be created or destroyed. So at the end of every chemical reaction, there must be equilibrium on the left hand side and on the right hand side. You must have heard balancing chemical equation. So quickly, let's look at the first chemical equation. Here we have elements like potassium, we have boron, we have oxygen. Okay, so what we need to find out is how many potassium do we have on the reactant side. Okay, let's do it together. We have potassium 1 here, then we have 2 potassium here, so it's not balanced. Potassium is 1 here, potassium is 2 here. So let's list out the elements we have before balancing. After balancing, we'll now also find out if you really did the right thing. Potassium, for example, is 1:2, right? So it's not balanced. If it is balanced, it ought to be either 2:2 or 1:1. So when I mean 1:2, it means 1 here, 2 there, so it's not balanced. So let's look at boron. Boron is 2 here, right? So that's 2:2. How many boron do you have here? Is 1. So what we have there is 1 boron. Is not balanced. Oxygen, we have 3 oxygen here, so 0 oxygen. 3:2. How many oxygen do we have here? 1. Is not balanced. By the time we are done balancing this chemical equation, you have things like 2:2, 3:3, 4:4, as the case may be. Now, when you are balancing a chemical equation, one thing you must do first is to look out for the elements that have least occurrence. You will start from them. Okay, remember, we want to make sure that the number of atoms of elements on the reactant side is the same as the number of atoms of elements on the product side. Okay, let's start. We have potassium. So let's balance potassium. How many potassium do we have here? We have 1. How many do we have here? We have 2. So what we do is to add 2 to potassium. When you add 2 here, potassium is now 2, right? Is now 2. So let's do something like this. I hope you are following. Is now what? 2. The next is oxygen. Let's balance oxygen. How many oxygen do we have here? 3. Is that 3? I hope you are looking. We have 3 oxygen here. Then we have 1 oxygen here. So for us to balance oxygen, we add 3 here to this side. So you now have, because normally there is a there is 1 here. So when you multiply 1 by 3, 1 times 3, it will give you 3. Then oxygen is already 3 here. Let's still go. So oxygen is now what? 3. The next is boron. How many boron do we have here? We have 2 boron. How many boron do we have here? 1. So we now introduce 2 as a coefficient. Boron is now 2. So boron is now 2. Right? Okay. Let's look at the equation again. Let's start afresh. Potassium is 2 here. Potassium is how many? What we have here is 6 potassium, right? So there is an error somewhere. So we cannot go with, if you say 3 as the coefficient, 3 times 2 is going to give you 6. So because that is 6 and potassium is standing alone here, we'll clean this and put 6. Remember, the aim is to make sure that the number of atoms of elements are equal on both sides. So we also clean this and put 6. Take a look at it again. If you find any error, we'll start afresh. This is potassium, 6. This is potassium, 3 times 2, 6, right? Now, oxygen, 3. This is oxygen, 1 times 3, 3, right? Then we have boron. Boron is 2. How many boron do we have here? 2. What does that mean? The equation is now balanced. So what we now have, 6 is to 6, right? Are you following? 3 is to 3 for oxygen. Now we now have 2 is to 2. So the equation is balanced. I want to believe you are following. So this is how to balance a chemical equation. There is equilibrium. The number of atoms of an element on the left hand side is the same as the number of atoms of elements on the right hand side. We have another question. That's equation number 2. I don't know if any of you can try this, but let me, for the purpose of this life, let me make sure we take care of it. Okay, we have sodium. On this chemical equation now, we have sodium, we have nitrogen, we have oxygen. Like I told you, you will need to consider the element that have least occurrence and start balancing from it. We have sodium, nitrogen, oxygen. So what we'll now do is, we'll look at sodium is 2 here, 1, 2. Okay, let's still bring it down. Sodium is 2, right? Then nitrogen, how many nitrogen? How many sodium do you have the other way? On the product side, we have 2 sodium. Yes. So we can say 2 is to 2, right? Then how many nitrogen do we have? Nitrogen, we have 1 here. Nitrogen, we have 2 the other side. How many oxygen? We have 3 oxygen and 1 oxygen. So oxygen is equal to 3 is to 1. Now, if you look at this equation, you ask me, why are we having nitrogen to be equal? Nitrogen can be equal. Oxygen can be equal. Any of them can be equal. But once there is an element whose number of atoms are not equal, the entire equation is not balanced. Am I making sense? So let's balance it. First of all, let's balance nitrogen. Nitrogen has least occurrence. So nitrogen here is how many? We have 1 nitrogen. Then on the other side, we have 2 nitrogen, right? So what we'll do is we introduce 2 here. Let me use a green marker. When we put 2 here, we now have 2 nitrogen. 1 times 2 gives you what? 2. So nitrogen is now nitrogen 2 is to 2, right? Okay, let's balance oxygen. How many oxygen do we have here? We have 6 oxygen. 3 times 2 is what? 6. How many oxygen do we have here? We have 1 oxygen. So because we have 1 oxygen here and we have 6 oxygen here, we will now introduce 6 as a coefficient here. We'll add 6. When we add this 6, oxygen is now 6. So we have it that oxygen is equal to 6 oxygen here. Then 6, that's 3 times 2, 6 oxygen. So oxygen is balanced. Now let's look at this sodium again. By way of introducing 6 as a coefficient here, sodium is now 12. Yes, sodium is now 12 because 2 times 6 is 12. So that sodium that balanced initially is no longer balanced. Now we have to go back to the reactant side. How many sodium do you have on the reactant side? We have 2 and 1, that is 3. But here we have 12. So what we are going to do now is to introduce 10 as the coefficient of sodium on the reactant side. By this, we now have 10 sodium plus 2 sodium, that's 12. Then 2 times 6, 12. Sodium is now balanced. 12 is to 12. You can now say that this equation is balanced. I hope you are taking notes. You can watch the video again. When we are done with this live, we are going to drop it. You watch the video over and over again so that you will understand how to balance a chemical equation. Very easy. This is student affairs. You know, we want every Nigerian student, African student at large, to be able to make out good things out of the academic sojourn with their integrity intact. We don't encourage examination malpractice. That is why we take our time to teach some of these things on the board. Thank you for joining our live streaming. We will see you again. Make sure you are reading. Education is light. This is Student Affairs once again. Follow for more. Bye for now.